Imagine, this is futuristic, but it's not beyond science, that you have this virus now, and if you break a bone or you break your back or rip your eye, you get an IV of this antibiotic and you rejuvenate like a salamander.
I believe that each and every one of us has the power within ourselves to create the life that we really want. And I want to help give you the tools to make that happen. I'm Danica Patrick, and I'm pretty intense. I have to say that I was a little intimidated by today's guest, David Sinclair. He is a professor at Harvard, has over 35 patents. He owns labs. We had a fascinating conversation. I of course, did my research. Like, I don't know to ask about cellular programming. Anybody that's been listening to this podcast knows that I just truly love learning. And I just really love having scientists and doctors and experts on the show because it's part of that process. I think that we grow through, of course, that self-reflection and our own work, but we also grow through just learning more and just having that education of how to treat ourselves better and how to take care of ourselves better, mind and body. So today we're going to learn about how to take care of the body, and we're going to also learn about, the future of how we can repair ourselves. David is a scientist, but he specializes in the field of anti-aging. What his main focus is that quality of life. It's not about living forever. It's about being able to live more fully while you are here. And so we talked about the science, we talked about how to do it, we talked about the best kind of diet, the best kind of exercise, and basically I have to go back to this episode and listen so I can write down all the things that he said because it was a lot to soak in the moment, but there's a lot of amazing information in this episode. So take it all in, and if you have to re-listen.
Well, so we can't fix yet that presbyopia, but we can have a dead retina come back to life. So if you've got macular degeneration or glaucoma or just old age, then you get your vision back if you're a mouse. But hopefully we'll do it in humans. But it's proof of concept. We can talk more about it.
Yeah.
Proof of concept that we can turn back the age of a tissue.
Is it genetic?
It's a genetic treatment.
Okay.
But when we're not turning back, not changing the genes, we're telling the cell how to read the genes like a young cell does. And we think aging is caused by, if the genome were a piano, the piano player becomes demented, and we're bringing in a new piano player to play the piano. And basically it works, and you get back youth, you get back eyesight. So that's what's in the book towards the end. And I'm spending most of my time now trying to make this into a drug. That and 14 other companies.
That's because you're a brilliant scientist. And so I wasn't even going to, when I'm reading all of your accomplishments, your bio, what you've done, all of the projects you're involved with and companies, I struggled to pronounce all the words in it all. And I thought, I'm just going to say you're extremely accomplished. And how are you so driven to it? But then I thought, that's not fair. And I need to try a little harder and make sure that people, I just think that understanding for your knowledge and your acknowledgments for what you've done is such a nice way to set the stage before we talk about all of these things. So look, I wrote down some.
I'm not arrogant. You can do whatever.
High points of high points is what I'm calling them. So you have a PhD in molecular genetics. You're an inventor of over 35 patents. Professor at Harvard. You have the Sinclair Lab. Co-founder of at least 7 labs and on the boards of many others. Co-founder of the journal Aging. Your work has been featured in 5 books, 2 documentaries, on 60 Minutes, and in Morgan Freeman's Through the Wormhole. You have over 25 awards and honors for your accomplishments. And Time Magazine named you one of the 100 most influential people.
Time's up. We got to go.
Time's up. Time's never up for you because you are an expert in not aging.
Right. You're very kind. There are some bad things you could say about me, but we can stick to the good ones.
Why would I do that? You're my honor. I'm honored to have you as a guest, and I thoroughly enjoy learning. And while the show has a lot of, there are a lot of episodes that I do with people, and we dive into your personal life a little bit as far as what struggles you've had and the growth that you had from it. And I would love to talk about those things too, because it's part of the human element of learning and growing and relating and being inspired to do it yourself. But I also love to have episodes where we're all able to be educated and can open our mind up to new possibilities, obviously in this scenario specifically to science and the science of not aging, which is a huge business, gigantic business. So tell me about, some of the fundamentals of your upbringing and where you came from, and then just how you have been able to be so driven, so focused, and obviously excel so much in the field of science. And of course, then there's aging, but it's just science in general. I mean, you're well accomplished.
Well, thanks for having me on.
Yeah.
First of all, you're just as accomplished. So, but
I have a GED. Let's just keep that really. Make sure everybody knows that. You have a PhD.
But I haven't won many race car events. But I have been known to drive too fast.
Okay, good. I like it.
Not good. I lost my driver's license in 2 continents.
How?
How? I was just not behaving well. I drive safe now, but as a youngster, I had a need for
What
for
countries
speed.
were you in?
First lost my license in Australia, and then in the US.
Do you have it back now?
Yeah, I've been very good for the last 20 years, but I was a bit of a speed demon and drove sports cars.
Okay, so how did your parents feel about that?
I don't remember.
What were your parents like?
So my parents are very caring. If anyone's responsible for me being rebellious, it is partly my parents who let me do whatever I wanted, and they would never get really angry. They'd get upset, but so I was allowed to just play. I was naturally curious. I would go into the backyard, and I grew up on the edge of the Australian bush, and I had literally 1 million acres in my backyard.
Wow.
I could walk for weeks. And for that was my laboratory. I would pull apart dead animals and spiders and try and figure out how things worked. That's what I like to do. And I still do that. It's just now I get paid to do that, which is anyone who wants to be a scientist, that's what's great about it. You get to do what you did as a kid, but get paid, and then teach other kids. And so I was very curious, and I explored a lot. I've always wanted to know, where do things come from? And there was a river in my backyard, and I would follow it, trying to find the source of the river. And I never did get all the way to the beginning of the river. It was a long way, probably 50 miles away. Similar to Ponce de Leon, never found the actual fountain of youth, and I'm still looking for something like that. But it's a good metaphor for my childhood. Yeah, and I'm a parent now, so I'm not a good parent. I try to be, but it's very hard to let your kids really explore and do dangerous things because you worry too much. But I was allowed to do things that I would never let my kids do, just wander off and be gone for half a day.
I think that's the story of a lot of people, though. There is a lot more fear-based information out there. Perhaps bad things were going on, but you just didn't hear about it all the time. It wasn't on the news. It wasn't on social media. And so you weren't thinking about it. Yeah. And it wasn't part of your reality then that you thought, David's going to go out and he'll come back when the sun goes down. And whatever he does, I'm sure he'll be fine. Now we're thinking, and what could be? And there might be somebody out there. And what if? And then, oh my gosh. And that's just the nature of life, has become more fear-based, in my opinion. So,
yeah, you're right.
We used to be able to ride our bike anywhere, and now it'd be like, the driveway is probably the only safe place. We're going to keep those training wheels on. Where do you get the drive to see things through that are so, that have never been proven and that are so new?
Well, you look at history, there's plenty of pioneers who just want to do something for the first time ever. And that's what drives us. We want to accomplish something that we can feel proud of and leave the world different and better than we found it. And that's what really is fundamentally my fear, is that I don't want to be inconsequential. I want to die knowing that my life was spent doing something useful. And I think that's the basis of it all. And I was looking for something consequential to do with my life. I was a very depressed person in my early 20s. And I've never told anybody that. And the reason was that I was fearful that I wasn't going to live up to my expectations for myself. Because I was in Australia, in Sydney, and scientists in Sydney don't typically get jobs. And I thought I'd have to become a lawyer. And there's nothing wrong with lawyers, but my personality doesn't suit it. As soon as I got into a lab and started tinkering, pulling things apart, putting them back together, then I fell in love with molecular biology. So I immediately got a PhD in that. But the big question that I wanted to solve, which I still think is the biggest problem facing humanity, is why do people get sick? Okay, and the traditional way of approaching that is we're going to find a cure for that once it happens, or cure for cancer, or cure for heart disease, which is great. And I'll be the first to recommend that because my mother passed away from lung cancer. But if we were to stop cancer today in everybody across the planet, the average lifespan wouldn't go up by more than maybe 2.5 years.
Really?
Yeah, it's surprising, isn't it? The problem is the major cause of death and illness is aging. It's what causes heart disease and Alzheimer's. Kids don't get typically Alzheimer's. Why is that? We forget why. We're focused on what causes people to fall off a cliff, and we're trying to stop them at the end from falling off.
It's too late.
But we forget what drove them to the cliff in the first place.
Yeah,
and
what have you learned?
Wanted to figure out what drives us to the cliff. Why do we age? Why don't we stay young?
What was your first aha moment with figuring that out?
Yeah, well, so I came to the US in 1995 to figure it out using simple organisms, yeast cells we use for beer and bread. And I thought if we can't figure it out for a microscopic yeast cell, we'll never figure it out for humans. So let's start simple. And I was trained in genetics, fortunately in yeast genetics. And the first aha moment was that we could, I had to guess why the yeast were getting old. I had this aha moment, middle of the night, 2 a.m., woke up and suddenly all of the observations over the last year and 10 years before me, put it into a hypothesis, wrote it down in a book, which I still have in my office. It was October 16th.
What's the name of the book?
It's just my lab book.
Your book? Okay.
Yeah.
Okay, you wrote it into your lab book.
It's in the book. But there's actually excerpts where I wrote a theory on aging. I cut that out and put it into my current book.
Is this the digital versus analog, the theory of aging?
Yeah.
Please explain. Okay, we'll get there. But anyway, continue on with your aha moment.
So the aha moment was that I think we could figure out why an organism gets old. It was a yeast cell, but actually all I've been doing for the last 25 years is taking that idea and testing if it's true for us. And so far, it looks like it is very relevant.
Well, how do you do it?
Oh, how do you do it?
Yeah, I mean, that's the key. That's the magic sauce.
Oh, okay, so what do I think causes aging? Well, let me give you a very brief catch up on history. In the 1950s, we really had a big effort into figuring out why we age, and it was the nuclear era, and everyone was worried about DNA damage and mutation. So the theory was we damaged the genome, the DNA, and that's why we age. And you still hear that's probably what most people think causes aging. Many of us, myself included, thinks that's not right. That's not the main cause. Number of reasons why. You can clone people. You can clone animals for sure.
Right.
But I'm pretty sure it could take your cells and clone you.
Animal or person? Have you seen a cloned animal?
Not with my own eyes.
Have you seen a cloned person?
No, of course not. They don't
Such
exist.
Such a liar
but
now.
Barbara Streisand would tell you that her dogs are clones. And she paid a lot of money for them, so hopefully they're real. But they're identical to her previous ones. Anyway, so cloning,
It's okay. It's okay. I have to ask. I'm very curious.
No, it's a good question. But I trust that the scientific journals that publish cloned animals and show that they're healthy are real. But I would like to see a cloned animal, that's for sure. But what that tells us is the genetic material in an old animal, and we're animals, is still intact. So let's take it that the digital information, the DNA, is intact in our bodies. So why do we age if the information's still there?
Right.
There's another type of information in the body, which is not genetic, it's called epigenetic. And that is just a fancy word for the structures that read the DNA. Right? We've got to read the DNA because every cell has the same DNA, but not every cell is a nerve cell. Some are liver cells, some are skin cells. And the difference is that it's a different pattern of which genes are on and off. And that's what makes us healthy babies. It starts with one cell, you get 26 billion cells, each one with a different pattern of what we call gene expression.
Can you change your epigenetics? Can epigenetics be changed, or is it a gene expression? Can you change the expression? Is that the same thing as epigenetics?
Yeah.
Okay.
Yeah, you can do it right now. Do you want to do it?
Yeah.
Okay, hold your breath. All right, you just did it.
Yay!
It's easy, right? So 80% of our longevity is non-genetic. It's how we live our life. And having lack of oxygen, so you're running, having a lack of food, fasting, being cold and hot and shocking your body is also a way to make your body fight against the ravages of aging. And it's all about preserving that epigenetic information. So I can explain how that works.
Please.
So we didn't really know 50 years ago what the epigenome was. We just knew that it was there.
Okay.
And we know that it has to be there because you make a baby, and a baby is from one cell. But what the epigenetics people, the scientists who study development of a baby, they didn't think into the future. They didn't care about aging. That's someone else's problem. But I think that aging is merely unraveling of what happened up till birth. So cells use their epigenome to play the right music on a piano to make perfect bodies, essentially perfect if you're lucky. But what happens during aging, I think, is that the cells lose their ability to play those genes in the right way. The gene expression gets messed up. We call it epigenetic noise. And cells, 80 years later, have forgotten their original identity. And that's aging. That causes disease. That causes heart disease and frailty and Alzheimer's, I believe.
So how do you forget how to play your genetics?
Well, so the genes are controlled by bundling them up. So DNA is a string, 6 feet in every cell. And it's not just flailing around like a piece of string. It's actually bundled up, either into big loops that are opened up, so the cell can read those genes. And you get groups in these loops, groups of genes. And then genes that shouldn't be on. Let's say if you're a nerve cell, you don't want the liver on. So you bundle those up tightly, like you would take a hose and spool it up on your driveway. And those are the tight bundles. So you got bundles and loops, bundles and loops. And that gets messed up. And one of the ways it gets messed up, we've shown, is that if you cut or break a chromosome, that's a disaster for the cell. If you break a chromosome, basically you're going to die as a cell, or you're going to become a tumor. This is really bad. So what the cell has to do is unpack those loops and those bundles to help repair the DNA, stick it together. We have these glue in the cell. And then they have to package it all back the way it was originally. And there are proteins that do all this, and they have to move from here to here to here to here. And some of them, we think, get lost. In the same way, these repair proteins are like the Army Corps of Engineer that goes to help Hurricane Katrina victims. They don't always come back to where they were. And over time, this movement, call it a ping pong match, you eventually lose those beautiful structures of loops and bundles. And that we can do in a mouse, and those mice look old, they get diseases of aging, they get the hallmarks of aging, which are things like loss of energy, loss of stem cells, all that good stuff. But as I wrote it kind of in a teasing way in my book, if you can give something like aging to an animal, you can take it away. And so we've been working on understanding not just what drives aging forward, but now that we have a better idea of what's doing that, can you slow it? Yes, we can. And can you reverse it? And that's where we are right now, is working on, is there a backup copy of the music of youth in the cell? And where is that? And how do you tap into it?
You said it. You talked about breaking a chromosome.
Yeah.
How do you break a chromosome?
Well, it happens in our bodies naturally all the time, a few times in every cell. So that's trillions of times per day. But we can accelerate that in the lab.
Okay.
We engineer mice to have an enzyme that cuts their DNA precisely in a few places. And we can turn that on with a drug, just a chemical we put in their water or food. Mm-hmm. And then it cuts their DNA for a few weeks when they're young. Mm-hmm. It all gets put back together nicely, so there's no mutations. The DNA information is still there. But then we wait, and over the next few months, they start to get old more rapidly, and they get gray and hunched, and they lose their vision, and they get dementia.
So we're constantly breaking chromosomes and repairing them.
Yeah.
So there's an issue with the repair, and that transporting back and forth of
these repair proteins.
Repair proteins that get lost, and then we're unable to then read the program, read the genetics. Epigenetics is not able to read the music, your genetics well enough to
so that's what I
continue
think.
with the same performance essentially as you originally had, and then you get old. Exactly.
And what's important about that is it means that the information to be young is still in your body even when you get old. We didn't know that until recently.
So what is NDA then? NAD.
NAD is a molecule.
Because I can't say the word, so I'm going to ask if you'll say what NAD stands for and then tell me what NAD is.
So NAD, it stands for nicotinamide, which is a form of vitamin B3, adenine dinucleotide.
Yeah, now everyone knows why I couldn't say it.
It's basically vitamin B3 attached to a sugar attached to phosphorus.
That's much better. It's still difficult, but much better.
But it's a tiny little chemical, and it's one of the most boring chemicals in biochemistry.
But isn't it important?
It is. We didn't know until the 2000s that it was linked to longevity. We thought it was a housekeeping molecule. I mean, don't get me wrong. It's important. If we didn't have NAD, we'd be dead. Right?
Yeah,
in seconds. It's required for most chemical reactions and the energy. It sustains life. But that's still boring stuff. It was all figured out in the 1960s. But when we came along in the 2000s, we discovered that there are sets of enzymes that protect the body against disease and aging. They're called the sirtuins, and they need NAD to work. And they don't just need a little bit of NAD, they need a lot of it. And when you're sick and when you get older, you have less and less of this NAD molecule. You don't make as much and you actually chew it up, we think. And so what happens is these sirtuins, which are keeping all the packaging correct and making sure cells don't get sick as they get older, they lose their activity. So without the NAD, they don't protect the body. Now, there are some ways to boost up NAD. I'm sure you want to hear about that.
Of course.
Well, one is stay young, but that we're still figuring out how to do. But the other things you can do are you'd be surprised to learn that exercise, well, you may not be surprised, exercise and being hungry.
Exercise is good for you? Wow.
It is, but did anyone know why?
Straining the body. You're talking about all kinds of things like you're talking about exercise, you're talking about hot and cold, you're talking about starvation. So you're talking about extremes. So mitochondria, adaptation, something like that. I mean, I'm really a little embarrassed about saying these big words, but I'm not sure what I'm talking about. But
you're absolutely right. So I have a saying in my lab is we can always give an explanation, but we have to ask the question why 5 times. And so you've just said something that's true, which is sirtuins and diet, all of these good things protect the body, okay? But then you got to ask, well, how does that happen? And so what I'm proposing is that the NAD levels are activating the sirtuins and stabilizing the information in the body and repairing cells. And that's the reason why exercise and diet is good for you. It's not that blood flows around. It's not that just that mitochondria are boosted. It's that we have these innate defenses in our body that become complacent if we sit around, if we eat too much food, if we don't exercise, because they evolved to keep us healthy when times were tough. Problem is, in our world today, times are never tough unless you make them tough. So you're right. What doesn't kill you makes you stronger. But what's exciting about the science of aging is now we understand why. There are these genes that we have. Yeast cells have them. We have them. Bananas have them. Whales have them. And they serve to protect us. But we've been trying so hard to get rid of any adversity in our lives. They don't bother working anymore.
So how do we, you're saying NAD is important and it helps the, what was the
sirtuins?
The sirtuins.
Yeah.
And that, so how do we produce them? You talked about exercise. You talked about food.
Right.
Why would we stop producing them if we, let's say, you know, I eat healthier now than I ever have.
Yeah.
So, you know, seemingly doing better job with the quality of my food, the sourcing of my food, the amounts, whatever it is. Like I'm working out more. Say I'm doing a better job with all of it. Am I now producing more NAD?
You should be.
So what if I never stop doing that?
Well, we don't know of a way to continue making it at the same levels. It'll eventually go down.
No matter what you do.
Right. So that means we might need a little help.
I'll be your demo if you want to do a test on someone who never drops their amount of fitness and I'll stay on a really healthy program if you want to use me. It's fine.
Yeah. Well, it'll just require a few tissue samples.
Okay.
We'll need a bit of your liver, your muscle. Is that okay?
That's fine. You know,
Maybe
I'm a girl. I'm so used to going to the doctor anyway. My brain. Whoa, we got to stop there. Okay. This is not an animal lecture session. Okay. So what about cellular reprogramming?
Yeah.
This is something that I've read about that is kind of scary in some way because you're talking about creating it and being able to give someone a cellular reprogramming.
Mm-hmm. Yeah, this isn't stem cell transplantation. This is something very different. This is taking all the cells in the body or in a tissue like the eye and reprogramming them to be young again. Not to behave like they're young, but literally be young again. And it's a hot new field. There's only 4 of us in the world that do this.
Is this what you were talking about as soon as you came in here about eyesight and being able to, okay.
Yeah.
Fantastic.
Right. So let's go back to an analogy. Or let me give you a new one. So a compact disc. You remember those things?
Oh, yes, of course.
We could fit 10 songs on them. They were brilliant.
I remember cassettes, but anyway.
Yeah, me too. I don't remember.
Of course, you only look like you're 20, so I'm not sure how old you are. Maybe you don't remember cassettes.
Well, I'm 50, so everyone can judge.
Very confusing.
But these CDs, they're a good analogy because there's 2 types of issues with a CD. One is you can lose the information, which is the silver stuff, which doesn't happen much. So that's like our DNA.
Okay.
But the epigenome reads the songs on the CD or our genomes.
Okay.
And aging is like the scratches, right? If you take sandpaper to a CD, it's not going to play very well.
Right.
And we've been looking for things that slow the scratches down, like NAD, and exercise and diet and all that slows the scratches, but it doesn't. If you've got a scratch CD, slowing more scratches isn't going to help you much.
Okay.
What you need to do is polish them. So that's epigenetic reprogramming, is getting rid of the scratches. Or in the case of a piano player, the demented pianist, we get rid of the pianist and put a new piano player in there. And now the music is beautiful again. So how do we do that?
How do we do that? It's a whole bunch of I've read these words and I'd like you to explain them and how and which and why and how do we become young again?
Oh.
Well, how do you buff it? How do you get rid of the scratches?
Well, we're talking about really the cutting edge of science. 5 years ago, there's no way I could talk to you about this, even if we knew that.
Legally?
Well, there's a code of ethics in science that you don't talk about things before they've been fully vetted by everybody. The problem with science
so you're saying that once you start talking about something, it is so far down the line of being proved and approved that this is
Well, we used to not
This is
talk
a
to the
given.
public, right? It was you publish something and maybe a newspaper might call you and they'd get the story wrong anyway. That was how the public saw science. But now we're in a world which is beautiful, and just in the last couple of years, thanks to folks like you, is you can talk directly to the horse's mouth. And,
Thanks.
But I'm the one that's the horse.
Sorry.
But the issue is that science is taking longer and longer to publish. The work that I'm about to tell you about is based on 10 years of work that hasn't yet been fully published. It's out there. It's on the internet. Anyone can read it. All of our colleagues have read it. But because it's now basically get in line and you have to do another 2 years work after you finish, because our peers are very tough on us.
for what? What is the 2 year?
Well, the 2 years, or at least a year for a really good journal, is so the way science works, and you probably know this, is you work on something, you write it up, you submit it to a journal. The journal gives it to your fiercest critics, and they anonymously can trash you and give you advice on what to do. And typically, because they want to look smart, they'll give you about a year's worth of work to do. Even if your work is really great, doesn't matter. You always expect to have another year of work, typically. Problem with that is the world's moving too fast to wait 10 years, right, for this information. So now what we do as scientists is we put it out there for anyone to read, to criticize, but we're still locked in that, peer review, which is fine. And ultimately the peer review article will be the record of science.
Okay.
But there's this period now where science is more public than ever before. And we can talk about it in ways that don't damage our
So
career.
what does that record mean? Once it's like really finalized and you've gone through that due diligence of final phase of whatever you have to prove to someone else, what does that matter?
Well, so we scientists like to pretend that we are discovering the absolute truth. Never mind that theories of science are always replaced and revised. There's never a full truth, except maybe the laws of thermodynamics. But even Newton and Einstein have been replaced. So, there's no truth, but we do our best. And the way we do that is we have to go through this hazing with our colleagues anonymously. Once we get through that, if we make it, we get approval to publish. It gets published in a scientific journal, and now that's there forever. And the only way it can go away is if it's discovered that you made up this data or you made a big mistake, and then you have to retract it and take it off the record or offline, which is really damaging to your career. Fortunately, nothing like that's happened to me, but it happens more often than not, and you fear it because people then will doubt you going forward if it's fraud, or typically it's not your fraud. It might be someone working for you who was desperate for their career. But,
Of course.
but that's what the record is. Once it's printed, it's supposed to be like the Bible. You don't change it after that. Anyway, so it's a slow process.
Okay.
And
So
my research is mostly published. A lot of it is about to be published.
when you say mostly published, how many articles have been published? What would you call them? You'd call them how many?
Articles. Scientific articles. Yeah. Just my lab?
Yeah. You.
Me. It'd be
Ones that you were part of.
170 or something. Wow. But what we aim for...
So you're really 50? 170, they each take 2 years. How old are you?
Yeah. Well,
Once you've finally gone through the 10-year process of figuring them out, obviously you're working on an incredible amount of these things simultaneously.
Right.
So what is it then that you're in this phase now where the information is out there for people to read? So what is this fantastic information that is allowing someone to, let's say, see again?
Yeah. So there's a group of us. So it's not just me as a loner, but still it's very new, which is exciting that everyone can hear about this, but very early. The idea is that we can take genes that normally develop embryos that are switched off when we're old. Even when we're teenagers, they're gone. Sometimes they come on in other animals. So if you cut off your arm and you're a salamander, you grow back a limb, or you're a jellyfish, you can be immortal and come back to life from a little piece. We know that that's possible. We've forgotten how to do that. We humans are pretty pathetic. If we get damaged, we're not growing back an eye. But the systems are there to do that, we think. And there are certain genes that control those processes.
Wow.
A fellow called Shinya Yamanaka won the Nobel Prize in 2012 with Professor Gordon, for realizing that this exists, that you can take old cells, skin cells, for example, and make them essentially age 0, take them all the way back to 0. And we call that's pluripotent stem cells. You've probably heard that we can now make stem cells in the dish. I could take your skin cell, turn it into a little liver or a little kidney or neurons and put them back into your brain. That was worth a Nobel Prize and more, and deserved. What we've done is we've said, let's take what they've learned about going back to 0 and say, we don't want to go back to 0 because we're going to have the world's biggest tumor in our bodies. We don't want that. But what if we take it partially the way back? Take youth halfway, not all the way. And that's tricky because if you do it too much, it's going to be problematic. And if you don't do it enough, it's not going to work. But what we've figured out in my lab, and this is the latest, is, and we're just revising this work for a big journal. So we hope to have this out in the papers soon. If you use the right combination of these genes, it's seemingly very safe, and you take cells back to being very young, but not all the way back. And when you do that, you get the restoration of function of important tissues like the eye.
So are you adding something in?
Yeah.
So this is cells.
Well, it's actually
You're depositing
interesting.
new
we don't put cells in.
Nope. Or genes?
It's genes. We revive the existing cells. So I'll use you as an example. You're young and functional, but imagine that you're 90. You can't see well at night. A lot of the nerves in the back of your eye are not working. What we are doing with the mice equivalent is we put a virus into their eye that carries 3 genes, and it just goes in there and sits there, and nothing happens. It's safe.
Are you saying this is a test, or are you saying this is part of the process?
We've done this in the mice.
Okay.
And this is what we hope to do in patients in a couple of years from now. And so the virus goes in, it carries 3 genes that reverse aging.
Okay.
Then we can turn them on with
You wouldn't think of a virus reversing aging, just saying.
Well, it's a domesticated virus. Okay. It's a delivery. But we won't use viruses. We'll use chemicals. We'll use a pill.
Is this natural or synthetic, or is this lab made?
It's very lab made. It's called an adeno-associated virus, which is used currently to treat genetic diseases. So we can actually, we scientists, not me, fix genetic diseases.
Is this CRISPR?
It's like that, but this is gene replacement.
Okay.
And so there's a company, for instance, called Spark Therapeutics, where
oh yes,
they are curing blindness in patients who have a genetic defect.
Well, as I said when you came in, I was watching a program called Unnatural Selection, and I think they were featured in it, and it made me a little frustrated when they talked about how much it was. This is the problem with this. That's why we're trying to bring the cost down. It's unfortunate when you watch a guy say, it's not about the amount that of the product or what it takes to make it. It's really about what does your eyesight mean to you when you're figuring out a cost. That's what was in the program. I'm like, wow, this doesn't go over real well when it costs $800,000.
Yeah,
because they're taking advantage of something that you want so badly. So
yeah, well, in their defense, it probably cost $1 billion to get to that point.
Understood. I mean, I don't overlook the fact that there's a decade or plus with research that goes into it, and time and effort from brilliant minds like yourself and so many others that are in a lab working on it, and the lab itself. And yes, there's costs associated with it, but it's still it's unattainable, right?
Right. The good news is, though, that these costs don't stay high. They come off patent, and other people develop cheaper ways. It wasn't cheap to buy an airplane or fly on an airplane. It's still not cheap, but it's certainly affordable to most people. We all have supercomputers in our pockets now that used to cost.
Right.
So, but I'm with you. I'm not trying to make a lot of money out of this. It's all about trying to help people.
Mm-hmm. How accessible is that? Is this accessible yet?
Well, the reprogramming 2 years from now, we'll know if it's working.
Okay.
And it should be fairly quick. Within a matter of a few weeks, we'll know if patients
what are the other
get
kinds of
eyesight.
things that people will be able to have fixed or cured other than eyesight?
Well, we only chose the eye because we're crazy, because we figured it was the hardest thing to treat.
Start there and everything else is cake.
Pretty much. We also were driven by the fact that I have a very good student whose parents are interested in the eye. So we said, is it okay if we reprogram the eye? Sure. Go reverse aging in the eye. So he did that.
There you go.
But my point is that we could have reprogrammed anything. We just chose the eye and it worked. But it probably will work in other parts of the body. We've given it to the entire body of a mouse, and those mice now, over a year later, are still very healthy.
So liver function?
All good. They seem healthy.
Was it cure heart disease?
Well, we'll see. We don't know yet. But we do know that those cells in the eye, the back of the eye, their age goes back to being young again. And they start playing the piano, turning on the genes like they were young again, because they are young again. And we actually turn back the clock. So this is the important thing, that we now know that there's a clock in the body that we can measure. It's not the telomeres that get shorter. It's something else. It's chemical modifications on the DNA that accumulate like crust over time. And we can read that crust and put it into a computer, and it tells us exactly how old we are, and mice, if you're measuring mice. And within a few % error, and even estimations of when we're going to die. But that's a shock.
I mean, they make movies about that, of course, and they, you have it written on. You're like, here's your due date, your done date, I should say. That's stuff that people don't necessarily. Some might want to know that, but
here's the good news.
Genetic testing on embryo or on fetuses, on being able to tell, or embryo, like when you do like I did IVF and had my eggs frozen. So when you do, then when you create the embryo, you can do testing, genetic testing on that, correct? And what can you find out?
Predisposition to diseases or any major genetic aberrations. You can find out a lot. You can't figure out intelligence and that kind of stuff.
You figure out if the embryo will turn into a baby, or if it will terminate in 3 months. Will it, can you tell any of that kind of stuff? You're talking about how long will you live?
You can. Mostly that's caused by broken chromosomes.
Oh.
Yeah. And the older the egg, the more broken it will be.
So mine are 33-year-old eggs, so not so broken or kind of broken?
They were frozen when you were 33?
Yeah.
Okay. That's probably fine. 40 is the cliff.
Be 38 in March, so, still no kids. So that's a good thing I did that then.
It is. It really is. Though we're working on NAD boosting compounds for women. We have a company.
Is it an injection?
It would be a pill that would improve the health of eggs and make the ovaries younger.
Wow.
It worked really well in mice. We've got that in the works to be published soon.
How long does it take to be effective?
We just did 4 weeks.
Wow.
And it worked in horses, we think, in a small study.
Huh.
So we'll try it in women, hopefully, in the next 1 to 2 years.
Wow.
So that
in a couple of years, there's going to be some major stuff happening.
Well, yeah, there's a lot that can go wrong in that time. But there are a lot of my colleagues who are working on this as well. So someone's going to succeed. Like I was telling you when I first came in, there are dozens of companies, and I'm involved with a lot of them trying to push them out. There are some results that are reading out from a company that I didn't start, but some others did. And that'll be the first man-made drug if it works for aging. And we'll know in the next couple of months. So the important point is, I talk a lot about mice, and people are like, oh yeah, mice, who cares? And this is 20 years away. It's not. That was 20 years ago we were in mice. Now we're doing lots of clinical trials, and it's going to happen.
Yeah. Do you, I kind of want to end up talking about, I really want to understand, I did a deal with a company who, it's called One Cure, and it's they work with animals, but the essential basis is that it's one cure to cure cancer for dogs or animals as it is for people.
Yeah.
And so there's so much transparency in how we operate overall. And so then, of course, then you wonder, what causes, you're talking about broken chromosomes being the source of aging and the source of disease and things that that kill us or make us deteriorate. So is there essentially one potential drug or medicine for everything?
No, not yet. Not yet. most of what we've developed as a field are pills that, and occasionally some injections that work a little bit. So they will slow down aging. So I'm taking some molecules that are not reversing
Oh, I
aging.
heard on Joe Rogan how many things you take, and I started writing it down, and I was like, yeah, I don't know where to get that stuff.
Well, yeah,
That's a cocktail list. That's an expert mixer. But I'd like some, maybe.
well, none of it's a magic bullet. They're all, we'll talk, but the really important thing to know is, just like exercise won't make you live forever, or fasting won't make you live forever, we now know how to slow things down, we think, but we can't reverse it. So there's no magic bullet right now. But
There's
that's
no
still
one
better.
magic bullet for everything. There's
not
nothing that makes
we
the
know of.
chromosomes and all their little workers communicate and never lose their song.
No, not that we know of.
I feel like I'm not really describing this in a very elegant way, but I'm sorry. I can't remember all the words you said. Just trying to remember the visual of it. But so there's not one, do you believe that's ever possible?
Well, the reprogramming is pretty interesting. If we can reprogram the body in its entirety in a safe way. And remember...
What will be the treatment then for the reprogram? What is it right now?
Right now, it is a virus that you give that delivers 3 genes.
So it's like an IV?
Right, or in the eye, wherever you want to put it.
Okay.
It spreads throughout the body. And then when you take an antibiotic, the antibiotic we've engineered, engineered the genes to be turned on by the antibiotic. So it's not important that it's an antibiotic, but we needed a chemical that you could give to the animal or the patient, turn on the system, the 3 genes, and then you don't want them always on. You just want to fix the eye or the body and then turn it off again. So you stop the doxycycline, which is the antibiotic we use. So it's got an on-off switch, which is nice, right? It's going to hopefully be safer for that reason. But imagine a world where when we're young, let's say we're in our 20s, early 30s, we go in and we get our viral treatment. And so that spreads throughout our body and it just sits there until we need it. So when might you need reprogramming?
Would that be like a vaccination then?
It
or
would be.
Is it not?
No, it'd be like a vaccination.
Similar?
1 or 2 injections, that's it. It's what we do for the mice.
In your life?
In your life, and it's there. Now you're genetically modified, by the way.
But we're always being genetically modified, right? Like you said, hold your breath, you're being genetically modified. Is that correct?
Epigenetically modified.
Epigenetically modified.
Yeah.
You're talking about genetically modified.
Putting in extra genes. 3 extra genes. Well, we've already got those genes, but they're not turned on by an antibiotic. They're turned on when we're very young. But we've made a virus that will deliver those genes so that we can turn them on when we want, which is when you get hurt, when you break your spine, when you damage your eye, or potentially when you get old. So then you imagine, this is futuristic, but it's not beyond science, that you have this virus now, and if you break a bone or you break your back or rip your eye, you get an IV of this antibiotic and you rejuvenate like a salamander. Or you reach 60 or whatever you want and you go to your doctor and say, just had my epigenetic clock measured, doc, and I'm biologically 75. That sucks. Give me some doxycycline. Script for doxycycline. You go to your pharmacy, take it for 3 weeks, and you notice that you literally get younger. And you wouldn't just feel younger. If it works, you would look younger too.
What's the downside? There's got to be something that could go wrong here.
Yeah, there's plenty of things that can go wrong. The worst that could go wrong is if it goes too far and you get stem cells and they turn into a tumor. That would be a nightmare scenario. So we have to do a lot of work over the next 2 years making sure this is safe for humans. It's one of the reasons for going into the eye because it's contained and it's not going to spread.
Oh, interesting.
We haven't seen any evidence of any toxicity in these mice that have been given a high dose for a year now and turned on, and they're quite happy. But that's the nightmare scenario, that we do more harm than good. But for vision, I think it's a good bet that it's going to be fine in the eye.
Is there any? Does this have any effect? I mean, if you're giving a virus, essentially, you're getting an injection for a virus that's going to live in your body. And I feel like one of the things that I've been, paying attention to a lot is gut health and how much conversation there is around gut health. And then you think, oh, you put a virus in there. Now you're talking about an antibiotic, correct? Is that? I mean, that's what doxycycline is a form of it. And there's so much around that being so deteriorating for gut health and the healthy flora and bacteria, the microbiome of your gut, the healthy bacteria. So do you buy into the gut health being really important? And does anything that you're talking about affect that?
Definitely buy into the gut health. There's no question. It's a huge field now and it's growing. That maintaining that gut barrier is essential. And we think part of the problem of getting old is you lose that and you get inflammation and things leak into your body from your gut.
Leaky gut, is that?
Leaky gut, exactly. So I'm definitely on that page. But these viruses, you're going to give them in your bloodstream and they're not going to affect your microbiome, we think. But the positive thing about this is that we're talking about basically the Wright brothers have made a glider, and it doesn't mean we're going to be all riding in gliders lying on our stomachs for the next 100 years. But it does mean we can fly, and we'll make improvements. Eventually it won't be a virus. It could just be a pill, could be a cream, something like that. The mere fact that there's a backup copy of youthfulness is the most important part of this discovery.
Whether or not we have that, are you still questioning that, or
I'm not questioning it anymore.
Do you believe that we have that is in our genetics?
Yeah, I mean, if you believe our data, and I do, obviously, otherwise I wouldn't try to publish it, that we can make cells young again and turn back that clock, the clock that we can measure.
There's going to be so many plastic surgeons that are going to be so angry at you. The vanity is out the window.
Yeah.
And there's also going to be drug companies that are going to be so mad at you because you're going to keep people young and keep the epigenetics playing the song that we were meant to have from a young age that keeps us looking and feeling our best, and we're not going to have diseases.
I hope that's a world that
right?
comes.
I mean,
people will still
we
get
should
sick
want
and die.
that.
But they'll
we should want that.
Of course we do. Of course we do. And pharmaceutical companies are smart enough that if they see something's going to be a big win, they'll get on it too. And
sure.
Already they're talking to me.
I was going to say, so what has happened then?
Right. So
they're talking to you about it?
Yeah. Well, and not just me. There's a whole growing field on this. Mm-hmm. Now, don't get me wrong. This is a new field, and not every scientist would agree with me. We're going to have to do the usual fight and see, let the data win, let the data speak for itself. That's fine. As scientists, we have to come up with theories and then we try to kill them. And if we can't kill them, then they might actually be right. So we're at that point. But I've been doing this for a while now. I'm 50, and I haven't published anything that got me into too much trouble.
Have you injected or ingested anything, any of your own products?
I have not injected myself with virus. It's theoretically feasible, but I'm not going to do that.
Would you?
Well, here's a good question. If I was 95, I wouldn't have much to lose, would I?
Right.
But I still have hopefully another 30, 40 years to go. So I always do these calculations, risk reward. And the older I get, the more risk I'm tolerating.
Yeah.
Makes more sense.
That makes sense.
But gene therapy is very different than taking a little natural molecule. Some of them that I take are natural. So that's fairly safe. But gene therapy, I don't know. I would probably have to see a lot more safety studies before I would embark on that.
You probably would have some 90-plus-year-olds that would sign up for that shot.
Every day I get people in volunteering.
Are you allowed to do it?
No, I wouldn't. No, there's no way. It's illegal. But
what if it was
your
dad? What if it was? Are your parents still alive?
My father is. Yeah.
What if your dad wanted it?
Yeah, that's interesting. You get into these ethical dilemmas. If he was dying, it's still unethical, and I don't even think it's legal to pull out something from the lab and give it to someone.
No, but nobody needs to know.
Yeah, well, I'm not saying on record
we're
that I would
talking
do that.
Theoretically here.
Well, theoretically.
Theoretically, would you give it to your dad if he was in a position to really need it?
Well, I don't know about that. It could do some harm anyway. But if he only had a day to go, nothing much.
Well, what's
to
the
lose.
harm then?
It's true.
It could do some harm. What's the harm?
Well, let me ask you, would you do it?
Oh, absolutely. If I thought I was, I mean, right now, today, no, because I would try and do every other therapy I could that would take care of myself in the best way. I still feel good. If I was at a point where I felt absolutely horrible, if there were things that were threatening my quality of life to such a degree that it, either way wouldn't, what do I have to lose kind of a thing, then yeah. I mean, you would, of course, want to hang on. You would, of course, want to do whatever you could and be able to live longer. Now, the question of would I want to live till 200, right? If you're saying aging doesn't matter, let's just throw out a giant number and let's just say 200.
Yeah.
I don't know, right? Like, I'm not sure. What's the point of life? Like, what's the point of life to you?
Making things better, being productive, being useful. That's what gives life meaning.
So
for most people.
So say you've mastered the game of aging and we just live forever.
Yeah.
Then what?
Well, then you work on another problem to make things better. We're never going to perfect everything in the world. We got to figure out how to get off this planet as well. Lots more to do.
Would you live your life any different how would you live your life different if you were going to live till you were 200?
I don't think I'd change a thing. I'd probably drive a little slower and more carefully. Right? And
I wouldn't.
You wouldn't. Yeah, you're a better driver than me. But we have to be careful.
Well,
if
there's
we live
shots
longer,
for that, I'm a salamander. Just grow the arm back. It's going to be fine.
Right. It's an interesting thought experiment. If you lived for 1,000 years, you probably wouldn't cross the road without help. It's too dangerous.
What do you mean?
Well, it's a huge loss to die at 100 if you're going to live to 1,000. And there are a lot of risks that we take. Crossing the road is pretty dangerous. Not wearing a seatbelt is very dangerous. And we take these risks. But no one wants to die when they're 100 if they've got another 900 years to go. We don't let kids now ride in cars without seatbelts because it's a huge loss if they die. And so that's the calculation, that you take fewer risks the longer you live.
So are you really not living then?
I think that's a good point. So I come from Australia, and what I love about the US compared to Australia, they're both great countries, so
yeah,
I'm not
I've
complaining.
been to Australia too. It's beautiful.
Yeah. But what's different about Australia is that the government doesn't tolerate any major risk. So total ban on fireworks and speed cameras essentially on every other corner. And it takes the fun out of life, even if life is longer.
I think of Australians, and I feel like a lot of them I know are kind of crazy, so you're surprising me right now.
Yeah, it's unfortunate.
I mean, you're crazy. You're trying to keep people live forever.
Not forever, no. But what I'm trying to do, I want to say this is a good point to say, that I'm not trying to make people live longer in an old way. I'm trying to push people out for as long as I can in a healthy way and then have them die very quickly. And that's what happens in the lab. That's what happens naturally. If you live over 100, you die relatively quickly and cheaply. The medical cost to keep a 100-year-old alive when they get sick is 1/3 of people who die before 100. So if we can get people out further, it's going to be a lot of cost saving, because first of all, they'll be productive for more of their life. And then they won't cost as much when they get sick.
What does dying quickly look like?
Heart failure, kidney failure.
Really?
The mice in our lab, the really long ones, they're just overnight like that, pretty much. They die within a few days.
So the deterioration that we think there is really something more superficial in quality of life, as opposed to something like liver failure. It just happens.
Yeah, I mean, a horrible slow death is what happens if you don't worry about aging. Because what we do is we've kept the heart quite healthy with all of the drugs that we've got, but we didn't address the mind. We were not successful. So now we've got a couple of generations of people who live longer, but they lose their identity. And that's a nightmare situation. So what I'm working on is keeping the entire body healthy. And if I can't do that, it's not worth working on.
Well, let's talk about some ways that we can all really do it now, right? Like something that we've been talking a little bit about, like diet and exercise, but let's be a little more specific so that we can have the same answer that I had. Would you take the drug now? No, I wouldn't. I would do everything I could to try and take care of myself right now in the most natural way possible. So, first off would be diet. What's the best diet that we could carry?
Right. Well, there's not a one size fits all, and it's not a cop out. What I've done over the last 15 years is make sure that what I do with my diet and with what I take works for me. And so I've been quite scientific about it. Not everyone can do that, but through blood tests, I'm actually wearing a glucose monitor on my arm under here, a little patch.
Really? Do you always wear one?
Now I do, just for the last month, but I love it. It's actually now, I'm not just shoving food down in my mouth and forgetting about it. It actually shows up on my phone what I've done. And I love that feedback.
Interesting. I've heard too, I talked to another girl who does, tailoring of diet to keep your blood sugar levels, more balanced so that you don't get those hunger spikes and cravings. And, she actually suggested getting a little pinprick so you can check your glucose after you eat certain foods so that you can.
This is
so
way
that's
better.
obviously way, way better. So is there something in your skin then to?
Yeah. So
is that what a diabetic wears?
Yes.
Okay.
Yeah, this is the latest. It's a Bluetooth device. You put it in once every 2 weeks and it stays there. You shower with it. I was in the sauna with it this morning. It's really great. You feel a little bit more like a cyborg when you start, but you get used to it. And then now I wouldn't consider living without it because it's like driving without a dashboard.
Well, I watched a program. It was a TED Talk, and of course I was caught by the title, which was, "What is the perfect diet?" And I'm like, I want to know.
I'll tell you what I do. So I don't fall into the carnivore camp. So Joe Rogan and others are a bit upset with me. But I look at places in the world that tend to live long.
The blue zones?
Yeah, and they have a certain type of diet. Usually they don't eat a lot. They have periods of fasting, either religious or just that's how they live. They're very active mentally and physically their whole lives. And they have community. So all those things, we kind of know that. But I add another level of science and rigor to what I do as best I can. So what I do is, first of all, if there's one thing I could say that I think works the best and works for me the best is to eat less often. That's one thing that you can do.
So screwed there then.
It's hard. I know, because we've grown up with the idea that 3 meals a day is the right thing. And I don't think that anymore.
I'm at 5, so... I'm at 4 main meals and a snack, okay? That's how I go about it.
Oh, boy. Well, you're not eating a lot, that's for sure. Probably
Is there
better
a
to
difference
keep eating.
hormonally between men and women? Does that make a difference? I'm looking for an excuse here.
There's
You
definitely
can
a
say
difference.
no, it's okay.
No, there's definitely a difference, even in longevity. But I don't know about the period of fasting that makes a difference, unfortunately. It seems to work on both sexes. By work, I mean, if you fast an animal, it will live longer. Sorry about that.
So you don't eat a lot of meat.
Don't eat a lot of meat, and I focus on
what kind of foods
as much
do you
plant material as I can.
Okay. Do you eat a lot of beans?
No.
Do you eat grains?
Not as much as you might think.
So lots of vegetables. Do you eat fruit then? If
Not as much as you might think.
If you're checking your glucose, you're probably not biting down on a banana or some pineapple.
Right, I'm not, and grapes and all that. So I've
low sugar.
So it's leafy vegetables.
Yep.
This is going to sound very boring.
No, you're fine. Do you want to live forever or not? And by forever, I mean a long time and really healthy.
Right. Well, I don't want to live forever. In fact, I don't care about dying, as you heard from my driving record. But I've now become a role model, so I'm trying to do my best and learn what works. So the vegetables, I try not to eat a lot of sugar in my food supply. So fruit's okay, of course, but a lot of orange juice I wouldn't touch.
Right.
Yeah. And the leafy vegetables are good. The carrots are good. My wife cooks mostly. She loves to cook. And she's gone vegetarian at home, which has been great. Mostly because our children insisted.
Really?
Based on principles, yeah. We've got militant kids.
That's wonderful. I mean, I have such compassion. If I don't eat, the only kind of animal protein I eat now is really fish. And I'm guessing that there might be a day where I probably phase that out too. But it really has to do with ethics. I mean, it's just a horrible system.
Yeah, me too. I got into a debate recently with somebody that you can raise animals ethically and it's better for the environment. And I'm going to look at it. But I'm with you, I think. I don't need to worry about hurting mammals. I used to say I don't eat mammals, furry things, but they do taste good.
Yeah, it's not the problem with the taste. It's just I just
Yeah.
feel bad for the process. And, you know, I always say, I mean, you know, in fact, Joe, I mean, he's a hunter and I know that he is passionate. I mean, he eats meat. But if we all had to actually go hunt our own meat and get it ourselves, and we there was no factory farming, the landscape of eating meat would look a lot different. And the emotion behind it and how they're treated. You know, if I was walking down the street and, you know, all of a sudden 1 second it was over, that goes pretty quick. And I have heard that there are some farms that's how they raise their animals, and it is done in a much more abrupt way that is not, that doesn't create anxiety and fear for the animal. But look, death is death. And so I'm with you. It's a moral thing.
Yeah. Well, and health-wise, I tend to put on a lot of weight. I've got bad Hungarian genes, and
change them.
I would be
Just you need a shot for that.
Go back and
I mean, that would
change
sell
my
like
father.
hotcakes.
Yeah. So what we do, what I find with plant-based diets is I don't eat as many calories. So that helps with my weight as well. And so I'm not as hungry either all the time. So that's good. I'm not crazy. I mean, I'm not so particular. I'll eat fish. That's fine. I'm not so strict. I'm not the kind of person that says you can only eat one thing and it's my way or the highway.
Yeah.
But I think maintaining a healthy weight is good. Focus on vegetables. Focus on colored vegetables, because when your food is stressed, we believe that the chemicals they make turn on our own defenses. So those sirtuins that we discovered or linked to aging, we found that many of those chemicals that plants make when they're under adversity or stress, they come on, they make them, and then when we eat them, we get those signals. And it makes sense that we get those cues about our adverse environment from the plants we eat.
I mean, I'm going to have to jump to my favorite part. Look, it's like written here, and I'm like totally going to get to it at the end, but you just said it because I'm a winemaker. So, Resveratrol.
Yes.
Am I saying it right?
Resveratrol?
Resveratrol?
Yeah.
If I say it faster, it sounds like what he said. Is in wine.
Oh, yeah.
And one of the practices with wine, with making wine, especially high quality wine, is you drop fruit and you stress the vine. You stress the vine, so you stress the cluster to try and grab as much water as it can. It concentrates the flavor and thickens the skin. And you want to give it to, also you don't give it too much water. You want the roots to struggle and strain and find water. So it's all about the struggle to create the great wine. So, oh my gosh, interesting.
That's what you're doing. You're creating a very healthy product by doing that. We need to do the same to our bodies.
Drink more wine. Yes.
Make our roots penetrate.
Oh my gosh, I was so excited when I was reading about the benefits of that. And you take that supplement every day, is that right?
Right.
Yeah.
Yeah.
I'm not going to say it because I said it wrong. Resveratrol.
Yeah, that thing. Now we first discovered it 2003. We first published that, and with colleagues, of course, and we've been figuring out how it works for the last 15, 20 years. Well, at least 15. And it's been up and down. We first came out and said it activates these sirtuins that we work on. And we built a company. We made a drug here in New York. It worked quite well in psoriasis, the skin condition, in what's called a phase 2 study. And then, so the company was bought by one large multinational company, number 2 in the world. And then the number 1 in the world, for whatever reason, you can speculate, I'm not going to say publicly, tried to invalidate our science and said it's all wrong. And I got sandwiched between the 2 biggest pharma companies in the world with a debate about my science. Now, that's 10 years ago, and we've proven that we were right, and we've got more interesting data to come out that'll
So are you in that last 2-year phase where somebody can now come in and make you prove other things to be true or not true? And then it'll be available?
No, it's available.
It's
we published it in Science magazine in 2013, so it's a long time ago. It's all vetted. So this isn't speculation.
Well,
this is a done deal. But when it comes to public perception, people are all confused because the media said, oh, it's the greatest thing, 60 Minutes. And then oh, it's all wrong, and then it's just a mess, and no one knows
Damn
what to
media.
think. But what's great about new media is that you can talk straight to the scientist. It doesn't have to be a flash in the pan headline. So anyway, resveratrol works the way we said, which is activating the SIRT1 enzyme. The way we know that actually is we can change the enzyme so that it still works, but it doesn't get activated by that chemical.
Oh, wow.
We have a mouse that cannot be activated. When we give it resveratrol, it doesn't live longer. So that's the proof that it works the way we said.
So how much do you take of that a day? What is the
gram, roughly.
grams? A gram? How much is in a bottle of wine?
A milligram in a glass.
A milligram in a glass. So there's about 4 or 5 milligrams in a bottle.
So please don't try to have that much. It'll kill your liver.
How many milligrams does it take to get a gram?
1,000.
Oh, God. So I'm going to have to drink every day. Be really consistent. But you take a gram a day.
Yeah, and I'm still alive.
I'm going to microdose.
That might work over
Or
decades.
is a gram microdosing?
No, a gram is a lot. But it seems to work fine in terms of overall health.
How different? What does it make you feel? Do you feel any different?
No, I don't. But I measure myself with blood tests.
Yeah.
There's a local company. And I can see if something is causing trouble. I'm looking at enough things that if something that I take causes, I can figure out in a day if it affects my blood sugar, but other things take a few months to figure out. And resveratrol's been fine, and I've had my heart checked out, and it's very healthy.
Well, yes,
and
heart
young.
healthy. Yes, of course. So is that available?
People sell it. I don't sell anything, but other people sell it.
Does one of your companies sell it?
I don't sell anything, but my name is all over the internet with people pretending that I sell things. I spend a lot of money on cease and desist letters. There's more going out soon.
Fun.
Yeah.
That's a fun side of your job.
It's unfortunate.
All right. Well, fitness. What kind of exercise? I am very curious about this. My own fitness goes through many iterations.
Yeah. So there's a lot known actually, and if you were to summarize it, it's that any movement is good. Walk, run if you can, bike, run even further if you can. That's the overall thing. But the good news just in the last few years is people have figured out that you don't need to be a marathon runner or a cyclist in a triathlon to be able to have a benefit. And again, about this stress, get your body out of complacency. The high impact intensity training seems to be the best. Get out of breath for 10 minutes or 20 minutes a day if you can, or every other day. You don't need to just be running for marathons. Just lose your breath. And you know you're running enough or cycling enough when you can't carry out a conversation easily.
Right.
What you're doing then is telling your body, turn on your longevity genes and protect the body. And they stay on for a number of days afterwards.
Really?
Yeah.
How many days a week do you recommend that kind of exercise? The intensity. It's more intense.
Yeah. Well, what I'd do if I had more time and I wasn't on airplanes all the time, I would do it probably every other day or every third day, let my body recover a bit.
Is the recovery just as important as the activity?
It seems to be. And it also matches with periodic fasting. You don't want to always be hungry. You don't always want to be fed. You want to be fed, hungry. It's that.
So back to food for just a second, though, with the fasting, just to pair up with the kind of diet with fasting. How often? So periodic fasting?
There's a whole bunch. You can do what I do,
for periodic?
which is I don't need breakfast. I'm not hungry. I've seen my blood sugar go way up in the morning. That's natural, what happens to me.
From not eating?
Not eating, lots of blood sugar. It comes from my liver. It's making it. That's what a lot of people feel. If you're not hungry at breakfast, I would say don't bother eating it.
Okay.
I try to skip lunch if I can. I'm not always able to because I'm stressed out and I'm a stress eater. But I try to skip lunch. And then I'll eat a normal dinner. But not too much. I don't go crazy on 5 hamburgers or whatever. And I also, one of my tricks is I bought some really tight shirts and all of them are tight. So if I gain just a few pounds.
Welcome to the world of women.
Yes, it sucks.
But, now you know why we complain about our weight. Because you see these jeans? Yeah, I know when I've gained 2 pounds.
Yeah.
But it's true. I do think that's true with women versus men. they call them boyfriend jeans for a reason because they fit like a guy. And so they're loose and you don't know when you've gained 5 pounds, right? Until it's too late and you've gained 15. So that's fantastic advice. A belt probably also helps.
Well, you don't want to change holes in your belt. That's also the indicator.
Exactly. It's a great indicator, the belt.
Yeah.
Okay.
And so periodic fasting has helped me keep my weight down.
Okay.
Combined with exercise.
So you do this every day. So your fasting goes every day.
Right. It's a struggle.
Is it a 16-8 split?
Yeah. So I try to do at least 16 up to 18 hours.
Do you do the 20 and 4 split?
No, I can't go for a whole day without eating.
Well, it's 20 hours off, 4 hours on.
That might be what I do. Yeah, on a good day. I can't do the 3-day thing. So
3 days of fasting?
Yeah, that's real deep cleanse. And by that I mean at the cellular level, there's this process, autophagy. Have you heard of this? No. So autophagy is the word that means your cells are eating themselves. And what they do is they recycle protein as energy source. And that doesn't happen really deeply until after day 3 of not eating.
So this is to improve your health.
Yeah.
So if
Why
you
else
have,
would you do it?
Huh?
Well, it could be for religious reasons, but I think you'd only want to do it for health reasons.
Yeah.
It's not fun.
No, not at all. But what if you had serious issues and disease or things wrong with you?
Yeah. So
it helps you on a cellular level, right?
It does, and it's thought that it can delay or prevent the accumulation of misfolded proteins that cause many diseases, Alzheimer's being one.
Okay.
But yeah, if anyone has an illness, I'm not a practicing physician. I'm a PhD, so I can talk about the science all day. But if you're sick, please do talk to your doctor. What is interesting though is some diseases respond really well to fasting. Cancer being one of them. Not all cancers, but
is it true that cancer feeds on sugar?
It does.
Does it feed on protein?
Depends on the cancer, but most of them like to carry out what's called aerobic glycolysis, which is basically plenty of oxygen in the body, but they act as though there's not enough oxygen and they use sugar directly for energy, and instead of taking it through the mitochondria. Long story short, cancer cells get addicted to the blood sugar, to the sugar in the body, and by starving them of that, it seems to force them to kill themselves. So it can be beneficial. And there are drugs like a diabetes drug called Metformin that is also sometimes given to cancer patients to simulate fasting. And that seems to help too.
I would be in favor of something to simulate fasting. What about supplements then?
Well, that's what my work's been on. It's how to understand why does fasting and exercise work. And I think we have a really good idea, these genes. And then what molecules can you take to
right? And what can we get? Like I know that like there are probably some things that you're able to get a hold of that might be more difficult for us. No?
Yeah, no.
Well, then tell me
I'm
your
a regular
cocktail.
Citizen. I'm not doing anything subversive. So the resveratrol
I don't think
is
you're doing
available.
anything wrong, but you do have availability some.
Well, I've
You
been
have a
doing
lab.
this
You
for
have
13
7.
years. I also have, we're fortunate that we've carried out clinical trials and we have some material in my basement. So I actually go down and I just
sure. We all do. So what would you recommend then for
I don't
us
recommend
layman folk who don't have a basement of medicine?
Well, I'm a professor at Harvard Medical School, and I get into trouble when I say this is what people should do. So disclaimer.
So is it better? So what do you do?
What I do, when I don't have my own basement supply, I go to what everyone else would do is either go to the vitamin shop or to Amazon or an online shop and look for the following. Look for a reputable company.
How do you know?
How do you know? It's really hard. There are larger companies that have been around for a while. I won't name names, but if this is a company that just popped up in Florida or Utah, stay away until proven otherwise. They need to show a certificate of purity. Ask for that. And there's a thing called GMP, which is good manufacturing practices. And so look for a GMP in the US. Okay. Other countries have different measures, but that means they're pure. So let's take resveratrol, for example. I wouldn't ever take the 50% stuff because you don't know what's in the other 50%, and actually it can have a diarrhea effect. So you don't
Some
want to
might
do that.
not mind that.
Yeah. Okay. Well, I don't want diarrhea, so I've
I don't either.
no. Some people might. That is true. Not on a plant-based diet. It tends to help.
All
with
work
of that.
fine.
Yeah, that's another reason. But the now you've distracted me. So the resveratrol is
So
is
don't
available.
take the 50%.
Yeah, here's something that's important. So always go for high quality. I do anyway. Resveratrol has been looked at by thousands of people in labs. It's been studied a lot. And sometimes things work and sometimes they don't. That's science, right? Clinical trials, sometimes they work, sometimes they don't. More recently, people have gotten clever and realized that resveratrol is a very insoluble molecule. Chemists would call it brick dust.
Okay.
Right? So if you eat brick dust, it's not going to get absorbed. Same with resveratrol.
So what do you need?
Well, you need to put it in something that it dissolves in.
Okay.
It's not water. It's something like olive oil. What I do is I make a special type of yogurt, which is good for my, supposedly good for my immune system, and I just mix that with a couple of spoons, and I take that in the morning. And if anyone's going to get angry that that's breaking my fast and that's breakfast, 2 spoonfuls of yogurt, okay, I don't think that that's a problem. But those spoonfuls, those bacteria are very healthy bacteria. I make it myself.
Yeah. Oh. Do you ferment your own?
I do.
Wow.
From special bacteria.
I mean, I shouldn't say, wow, you're a scientist, but...
Well, it's not that hard. I just milk in a jar, add the bacteria and some other feeding stuff, shake it, put it in the defrost setting on my oven for overnight, and I'm done. And
is it ready in the morning?
Yeah, it's easy.
Oh, wow.
I don't sterilize anything.
By milk, do you mean real dairy milk, or are you
milk.
talking about like almond milk?
I don't know if it would work with almond milk.
Really?
We could try. But I use whole milk.
So you don't obviously have a problem with dairy?
I don't know. But those who do, this is an issue to figure out.
I'll stick with my coconut yogurt.
Okay. But anyway, back to resveratrol. That's what we do.
With the resveratrol.
I spoon it in, mix it, and I eat that. But the clinical trials where people have given it with food, it's shown promise, lowering your blood sugar, lowering your cholesterol.
Okay.
And again, the public doesn't have the time or probably the interest in reading all of these papers that I do. But let me tell you that there's a lot of studies where in humans it's beneficial.
Okay.
And so I'm still taking it.
Okay.
I was once asked by a reporter of the New York Times, isn't it a conflict of interest to be studying these molecules in mice and people and taking it at the same time? And I thought about it and I said, I want to be the first person to know if there's something toxic. Don't I?
Yeah, I think that's why I'm saying. Have you taken any of your own? Would you take the shot? Because that's the ultimate testament to the product is that you take it.
The day I stop taking something, you want to know because I've seen something.
Why I want to know what you take.
Yeah. Well, all right. Well, you're smarter than the average bear.
I don't know about that, but we won't. So resveratrol. Why am I saying that wrong? Please say it for me one more time.
Resveratrol.
Resveratrol. So resveratrol, and then what else do you take?
I take something called NMN, which is a molecule that the body turns into NAD. NAD we talked about earlier, boosts the sirtuin activity. We don't know if it has an effect on human aging, but in mice it looks really good.
Okay. So is that available to people? Can they get that?
Yeah, it's out there. So I'm going to tell you something that I've just recently decided to explore. So every day I wake up to hundreds of emails. Where do I buy this stuff? Can you sell it to me? I can't do that. I'm a scientist and I'm objective. I need to be able to be trusted. The moment I start selling something, then I'm gonna, you're gonna say, well, he just says that because he sells it.
It's true.
But then with this dilemma that I'm saying, here's what I do, here's what the science says, you're on your own. That's not fair either, is it? I struggle with that. What I tell hundreds of people every day, other than tough luck, I don't want to do that. So what I'm working with another professor at Harvard is the possibility of giving at least a third party the means to test products, and they can have a seal of approval if it's at least what they say it is.
That's fantastic.
Doesn't mean it'll work, but at least it's not grass
A
clippings.
vetting process so that there can be a third party that you trust that is approving, disapproving, and being able to identify the quality of these ingredients.
Right.
That's great.
So then I'm doing what I can to help everybody. So those are the two main things, NMN, which you can buy, and Resveratrol. The third thing is an interesting one that really worked for me. So I don't take things willy-nilly, right? I don't just take 5 things and hope that they work. I'm testing rigorously. Take it, stop, measure, right? So it's very scientific, even though it's a small clinical trial of my dad and myself and my wife, which, a lot of doctors would say is not good science, and I'm not going to publish it. But I have learned that there's one drug that works very well. I can talk about it. I think it's useful information for people. The third one is Metformin. This is the diabetes drug that is used in millions of people around the world. And it's given to people who have a certain amount of blood sugar that we call diabetes, type 2 diabetes. It's the first drug you get, and it's, as drugs go, very, very safe. The worst thing that tends to happen to maybe a third of people is you get an upset stomach feeling, which you can mitigate usually. But what doctors don't usually do is give a medicine before the disease happens. It's pretty rare, right? But more and more evidence has accumulated both in animals and in human studies of hundreds of thousands of people that show that people who take metformin are relatively less susceptible to other diseases besides diabetes, cancer, heart disease, frailty, Alzheimer's. And when I look at that data, I say, that sure looks like a longevity molecule to me. And it's in that pharmacy right across the street. So it's pretty tempting, right? And so what I did was I started taking it a couple of years ago. My father was already taking it because he passed the threshold of diabetes. And it's been great in terms of how I feel, how my body is reacting, and hopefully it's doing some good.
It says something if you feel different, because it is hard sometimes to know if something actually is making you feel. You're like, gosh, I hope it's like me getting facials when I was 20. I'm like, I don't know, I kind of look the same, but I'm hoping in 10 or 20 years it really pays off, and then finally in 10 or 20 years. But it's really nice to have that more instant gratification and confirmation that you're on the right track with things.
It's a long-term investment for sure, and I'm very glad that I started doing this in my 20s and 30s. It's hopefully now paying off. I haven't got any gray hair, and I'm
I do.
Not super old.
So you can find something to reverse that. You'd also put hairdressers out of business. So you're in the business of shutting people down. But no, this is, at the end of the day, there will always be, science is always going. There's always going to be advancements and learning, and it doesn't mean that there are, it's putting people out of business. They're just going to have to find new. And for all the new that you find out, they will find new to accompany it. So it's an evolution. It's not a problem. You just, if you're afraid to evolve, then it is a problem.
Right. An analogy is people used to say, well, if you make everyone wear seatbelts, what's going to happen to the body shop repair people? Well, they'll figure out other things to do, of course, but we need to save lives. So it's the same here. Yeah. If we can slow down aging and prevent or push off most of the diseases that cause our healthcare system to be overly burdened and will continue to get worse, then people will find other things to do. And we're not saying that we're going to cure cancer tomorrow as much as we're going to be able to cure aging. But I do hope that with these molecules and ones that we're developing through the FDA and can be prescribed, that people will live until their 90s and be able to play tennis and hang out with their grandkids, great-grandkids, hopefully.
The one last part of what we can do is sort of the modalities, outside of fitness and outside of food, what we can do. And you were talking about being in the sauna, but is ice part of that too?
It is. So I was skeptical. When I started writing my book, the publisher said, oh, you got to put this other stuff. It's all the rage. They said, cryo is so hot right now. Ha ha. I said, oh, come on, that's pseudo. Then I went with Joe Rogan to a cryo center, and I felt great, probably because I was still alive.
because it was so
It's
awkward.
the temperature of surface of Mars, for goodness sakes. But I looked into it, and so it's not a bunch of hooey. There is some good science, not just looking at people's physiology, but you can look at lots of people who have been doing this, particularly saunas. There's a lot of research on that in the Nordic countries. That mostly they're men for some reason, but mostly men who do this are protected from heart disease, or at least associated with protection. And you can go the other way. You can look at what happens at the molecular level, which is what I do. And at the molecular level, stressing cells, either by a bit of temperature or a bit of cold, does fit with the theory that you are boosting longevity genes. There's one called sirtuin number 3. There are 7 in our bodies. Number 3 responds to cold. And it helps make brown fat in our bodies. And brown fat's thought to be very, very helpful and metabolically
Make brown
active.
fat?
Well, you turn your white fat into beige or brown fat.
And then what happens with the brown?
So
What
the
does the white do and what does the brown do?
Well, it does 2 main things. So it's full of mitochondria, burning energy. So your metabolism ramps up. You can eat more without getting fat, which is good for us. And the other thing we think it does is they put out these little proteins that make us healthier. We don't know what they all are, but there's some evidence that they make the rest of the body healthy as well. You can take brown fat and put it into animals, and it seems to be helpful.
Is there any other colors? White and brown, is that it?
That and beige.
And beige.
Yes.
So this makes brown fat.
It pushes it towards brown, but the older you get, the harder it is to make brown fat. So you want to start when you're young. So I'm 50 now. I'm just starting doing this cryo. Actually, I do a cold plunge, which is even worse.
Yeah, I've done a few of those myself. In fact, there's some of us here, we know Gabby Reese and Laird Hamilton, and they do a ton of that there.
Right.
And I've done it a few times and brought my friends along. The very last time I did it, which was probably the 5th time, I actually enjoyed it. I was like ready to get in, probably because I was so damn hot from the sauna, being at 220 plus, that I was looking forward to the ice. But I really I probably was in there for 5 minutes. I was like, it just felt so good to me. Yeah.
You really do get used to it, and you can tell yourself it feels good. I'm not there fully yet. My son, who does this with me, he's now up to 15 minutes in this 3-4 degree Celsius.
Wow.
Yeah. So he's gonna have a lot of brown fat throughout his life.
I'm gonna make T-shirts. Brown fat is good fat. Brown fat burner. What does it do? Brown fat. What will be our T-shirt?
I'm a brown fat builder.
I'm a brown fat builder. Yeah. Bring on the brown fat.
Bring on brown fat.
Bring on the brown fat.
My fat is beige.
Your fat's yours? So beige. Mine's so brown. Cute. I'll let you know. I'll send you one. So, all right. Well, I like to wrap up by just asking what your greatest lesson in life has been.
Okay. I haven't even thought. So this is off the cuff. The greatest lesson in life is don't worry, it's going to be okay in the end. That what we worry about in our daily lives is not worth it. We live in utopia. Ask someone 200 years ago what it would be like to live like we do, never having really, most of us, to worry about food and shelter. Now we're living in nirvana. So when we get upset, somebody tweeted this or somebody said that about me behind my back, these are pretty minor things. And so that I've learned that on the very bad days, it's never as bad as you think. And on the very good days, it's never as good as you think. So try to be steady. So I'm now 50 and I don't go through these wild swings of worrying and then euphoria. Maybe I've learned to cope with my bipolar issues, but that's the truth.
Different episode.
Don't stress out too much. It's going to be okay. If you find a mission in life and stick to it, it's going to be okay.
I like it. Well, you've been sticking to your mission very well. I should also say that you have a book that just came out, right? Called Lifespan?
Yeah.
Lifespan, Why We Age and Why We Don't Have to.
Mm-hmm.
So thank you for that. I will be picking that up along with all of the supplements. And now I think we have your phone number somewhere, someone to contact you. So if I can't find it, I'll look for a recommendation of a source.
Yeah, I wrote down what I do in detail
Okay.
towards the end of the book.
Okay.
And then part 2 is what I do and why we think it works.
Yeah. Well, thank you. And congratulations on an incredibly successful career. And I look forward to a couple of years from now when everything's published and products are even, well, not products from you, but...
Well, maybe drugs. We hope, yeah.
More is accessible to improve quality of life.
Yeah,
Everybody wants that, so...
Right, and when we both come back 10 years younger, people will get suspicious.
Not a problem to me. Thank you.
Sounds good. Thanks, Danica.
Thanks everybody for listening to the Pretty Intense podcast today. I hope you enjoyed it. If you like what you heard today and you want to hear more, please click on the subscribe button.